Okay. Okay, should you see the desktop? Do you hear me? Is everything? Oh, I have my speaker off. Okay, can you hear me? I just turned my speaker on.
Yeah, we can hear you.
Okay, great, thank you. Okay. Okay, so first, the exam you took last week, I have it almost done grading. I have one more problem to grade. So that exam, you should see the grades by the end of today. Okay, so look for the exam grades by the end of today. And when you see the grades, the way it works, at least I hope this is the way it works, I've been writing comments on the exam documents that you turned in. That's why we want them to be one PDF file, because there's a tool in Brightspace that lets me write on the documents. So you'll be able to look at your exam and see how many points you got per problem and any comments I made. So when you do get your score, go look at your exam. You know, I'm not sure if you see them all at the same time or not, but you should be able to see the exam document you uploaded now with my comments on it and the points you got for each problem. And if you have any questions about how something was graded or something like that, please send me an email. And real important is add up your points. It's real easy. There's no automated system for adding points, so I have to do it in my head. So a real easy mistake for me to make is to add points. So when you do look at your test score, when you test, add up your points and make sure that I added them up right. Okay. And if you think there's a mistake, please let me know. Okay. So I hope those will be up there by today. And then I have to grade the other classes exam. Then I'll go grade exam one. I hope exam one will be graded by Wednesday or Thursday. Okay. All right. Okay. And see. So, any question about that stuff so far?
How is your wife doing? Is she still sick?
They gave her a week off from work. She had an infection that spread into her blood. So she's still on antibiotics, but the infection seems to be under control. Yeah. It's kind of weird. I don't know if she was supposed to go to the hospital and they could not put her in a hospital. She should have been in a hospital, but they couldn't put her in one because they're so full of COVID patients. And that's kind of scary. Yeah. But she should have been in the hospital and the doctor could not find a place, yeah, other than sitting in the emergency room. The doctor told her if you went to the hospital, you'd probably just sit for several days in the emergency room. So, but she is, yeah, thanks. She is doing better now. She's on her feet, but she's got a week off from work. Okay. So, yeah, it's just a weird thing that somehow she got an infection and it got a little bit out of control. Okay. So any other question about what we're doing right now? Anything to keep up with?
Are the two exams like our midterm grade?
Pardon me?
I said, are the two exams our midterm grade?
I'm not sure what you mean.
Like the total score, like both of those combined, is that our midterm?
Yeah, and if you want to, I mean, they're more than your midterm because there's two exams and a final, so they're a little bit more than half. There is no such thing as a midterm grade. I mean, that's something that faculty give as a heads up to students, but there's no official midterm grade. So it definitely is a status report. You know, it lets you know how you're doing. It's approximately a little over half of your total grade for the course. Yeah, because let's see, the syllabus. See, the two exams were together 30% of your grade, and you've had several homework assignments. So between the homework assignments you had in the two midterms, that's about half your grade. And then the final exam and a couple more program assignments will be like the other half. Okay, so it is about halfway through because the two midterms were total 30, plus you've had some of the homework program assignments already. And yeah, definitely you definitely want to look at what your exam scores are. They give you a good sense of how you're doing in the class. But the concept of midterm grades is really, it's not an official, it's a good idea to give students a sense of where they stand, but it's not an official thing. And it's also sometimes kind of hard, like how do I split this in half and give you a midterm grade? Yeah, so it's a ballpark thing. So the midterm grade is kind of a ballpark thing. And yeah, your two exams make a good sense of how you're doing, okay? I don't know if I'll have time to actually enter midterm grades. It may actually, that was supposed to be a little while ago. If you have any questions about your grade, please send me an email. You know, so if you have question about how the grades are going to be made and how your grades look so far, send me an email or make a Zoom meeting with me. Okay. Okay. So that's real important. You know, keep track. You know, keep track of as best you can with what your grade is, and that's why I'm trying to get everything done. This Friday, I believe, is the last day to drop. Is that correct? I'm pretty sure this Friday is the last day to drop a class. So a lot of your professors may be pointing that out at this point. Okay. Let's see. Anybody else? Any other question? So if anything comes up, yeah, any question about, especially with the exam, when you see the exam, see how it's graded, ask questions about it. If you're not sure how a problem is supposed to be solved, if you're not sure about a comment I made on the exam, send an email, ask about it, okay? Okay, so we want to start talking about arrays, okay? And if you notice that this chapter is called Arrays and References. References are something we've talked about, so we're going to talk about them again. Arrays are an example of an object. So we're going to be talking about two things. We're going to be reviewing some of the ideas of objects, including this idea of references, and we're going to introduce this new kind of object called an array. Okay, and let me give you an example of a program that gives you a little bit of idea why we want arrays. Let me open Dr. Java, and I got an example program here. Okay, let's read through this code. This program does something, and then we want to improve. Oh, Dr. Java's stuck. I have to quit Dr. Java and start it over again. Okay, not stuck this time. Okay. What this program does is it reads in from through a scanner a bunch of numbers and treats them as temperatures, and it records the average temperature. Okay, so it's going to read a bunch of numbers and record the average. So let's look how it works. Okay, so it creates a scanner so we could read. It asks the user how many temperatures how many numbers, which is thought of as temperatures, how many they're going to be. So then it reads in an int, which is the number of temperatures to follow, okay? Then we create a running sum. We're going to remember, to compute an average, you add up a bunch of numbers and divide by how many there are. So we know how many they're going to be. That's this number that we got from the user. Then we're going to add up the numbers as they come in, and then at the end, we'll divide by this thing. Okay, so now we loop that many days. So they told us how many numbers they're going to be, so we loop that many times. We say, give us, we prompt them for the number they're supposed to enter. So day I temperature, give us day's I temperature. Then we read in another int. And this program makes temperatures ints, which normally you would make temperatures doubles, but this one just made temperatures ints, okay? So you read an int. And see, here's the key. This is where you add it into the running total. So you're getting the total of all the grades. After you're done reading everything from the user, you can take the total, divide it by the number of days. Now, this is integer division normally, but see what they did here, this is what kind of, this example, they have to convert sum to a double because the average has to be a double. If you average 2 and 3, if you average 2 and 3, you get 2.5. So you need this to be a double. So I don't know why, this was copied out of a book. It's a nice example. You'll see in a minute like what makes this thing interesting. But this should have been double. I think I'll go back and change that. The sum should have, the temperatures themselves should have been doubles. But since they're integers, if you didn't have this, you'd get a messed up division here, because then that would be integer division without the remainder. And that wouldn't give you a very accurate average. Then you would average 1 and 2 and get 1. Okay. Okay. So then print the average. Okay. All right. So let me just run this. Now this is our basic idea. We want to add something to this program in a minute to see why we need something called arrays. Okay. So I'm going to give them 5 temperatures, and temperature of 3, temperature of 6, temperature of 7, temperature of 2, and a temperature of 9. Okay, and the average was 5.4. Okay, now here's the next thing to do. What if I want to know how many days were above average? You know, if I read in a bunch of temperatures and I averaged them, it would be nice to now know how many days were above average. Okay, now to figure out how many days were above average, I'd have to go back and look. Like the average was 5.4. So that was below average, that was above average, that was above average, that was below average, that was above average. So 3 of them were above average. Okay, now, but my program can't do that. My program, the way it's written now, it's impossible for me to go back and figure out how many were above average. Or does anybody, if I really wanted to do that, does anybody have a suggestion? How could I start? What would I do maybe to solve this problem?
Could you make a for loop and then have an if statement in there comparing the day to the average temperature?
Okay, that's what I want, but where would I put that for loop?
It would be after you calculate the average.
Yeah, it has to be it has to be after the average. So okay, so here's a for loop that's after the average. Okay, and here's a for loop where I want to compare. Yeah, essentially I want to compare temps with the average. Okay, so that's the right idea. I want to have some kind of for loop that compares the temperatures with the average. Okay, well, what can I do now? Notice it has to be after this for loop, because it isn't until I've read all the numbers here that I know what the average can be. Now, does anybody see what's my next problem? So I've got a for loop. I'm going to compare the temperature with the average. What's a sticking point here?
It needs to reference integers you already typed.
Yeah, where did 3 go? I typed in the number 3. Okay, that's one of the temperatures I want to compare with the average. Where was 3? Where in my program did the number 3 show up? So you have to read the code. This is a good practice in code reading and thinking. Tell me what line of code and what variable 3 showed up in. Can we see it? Where did 3, and it's also going to be the same answer for 6, 7. You know, where did my program get the user's number? Go through it carefully line by line. You know, okay, what's line 10 do?
It establishes a scanner.
Yeah, okay, gives us a scanner, nothing else. Okay, what does line 11 do?
It just prints something.
Yeah, it gave us this question, how many days temperature? It prompted the user. Okay, gave the user a message. What did this do?
You type in the number that is the next number of days.
Okay, so the user will give us a number that we do what with? The user gives us a number and
Give
we
it a-
do what with it?
Give it a variable name called num days.
Yeah, exactly. We give it a name. We give it a name called num days, and we think, okay, this is how many data points we're going to get from the user later on. So see, I typed in 5. So that told my program there's going to be 5 data points. 1, 2, 3, 4, 5. Okay, so that we prompt the user for a number, and then that number is how many times we need to loop asking for more numbers. So we give it a name so we can refer to that number. Okay, what's line 14 do?
Initialize the sum.
And what's the purpose of sum?
Counts the number of days.
No, we know how many days there are. That's num days. And then I will actually count them off when we get to line 15. See, I will count them. This is how many there are. And actually, I is the variable that'll count them, day 1, day 2, day 3. What's the purpose of sum?
Isn't that just going to be where the sum of all the temperatures is going to be stored?
Yeah, for what purpose?
For the average?
Yeah, because the average is total divided by number of entries. So this is going to be the numerator for the average. So we need to keep this running total to use as the numerator in the average. Okay. Now, what's the for loop do? And we actually just answered that a second ago. What's the purpose of the for loop?
To count the number of days.
Yeah, count off the number of days, exactly. See, we're going to let I count from 1 to the number of days. So we're going to count off the number of days here. Okay. Okay, for each day, now in this here, we're saying for each day, what does line 17 do?
It's just going to day, whatever number it is
So
temperature.
Yeah, so what do we call that? You're doing what here? See down here, what are you doing here? What's the purpose of that line of code?
Displaying a message.
Yeah, display a message to the user. Let them know what you want from them. Or we usually call that a prompt. The usual term for it is you're prompting the user. See, day 1's temperature. Then the user types it in. Then you'll say day 2's temperature, and the user will type it in. So you're asking. That's the message to the user that you're ready to. Then what's line 18 do?
It asks you to type another integer, and it gives it the value of next.
Okay, well actually line 17 asked the user to type in a number. So what's a better way to talk about 18? 17 is actually where we kind of ask the user. So what's a better way to describe 18?
18 stores the number typed.
Yeah, it grabs the number. You know, we think of 17 as asking for the number, and then 18 grabs the number. So from the console, from the scanner, it gets another int, and it saves it here. Now remember, my question is, where did 3 go?
I guess into the sum.
No, not yet. Where did my program put 3 when it read it from the user?
Oh, into
And next.
Next, yeah, next. Okay, so it put it in next. Then what does line 19 do?
It adds next to the sum.
Right, so it increases the sum with the running total. Okay, now you loop. Now you loop. What happens when you loop? How do we think of this? What's the for loop going to do? You loop, and this does what?
Increments it. What is
Increments
that?
what? So we think of it as what? You're now asking for
Day 2.
day 2. Yeah, see, now you're asking for day 2. So now you say, give me day 2's temperature. Now here's the tricky part. What happens to day 2's temperature?
Gets stored in the next.
So what happened to day 1's temperature?
It went away.
It went away. Yeah, we lost it. Okay, now why is that important?
Now you
Why is it-
can't you can't retrieve it for the for loop, the next
Yeah,
for loop.
now we don't have a way of comparing. We don't have day 1's temperature anymore. Once it got added into sum, it's gone from us. Okay, so we don't have it to compare again. So what could I possibly do to solve this problem? Not using anything new, but using what we know, what could I do at this point? Down here, I don't remember what the temperatures were. What do you do to your friends when you forgot something?
What do I do to my friends when I forgot
Yeah,
something?
when you forget something, what do you need if you forgot, like our program has forgotten something. When you've forgotten something, you need to do what?
Need to be reminded.
You need to be reminded. Okay, how can this program be reminded?
You make it again.
I'm not sure what you mean. What do you mean make it again?
Make a new int.
No.
Would you make another variable for each temperature
To do what with?
to store it for later?
Oh, okay. That's a real good point. What if instead of, now that's what we would like to do, but can you see what the problem would be there? Like what? See, I only had one variable here. All the temperatures went into one variable.
Right.
Why can't I have as many variables as I need?
I guess you don't really know how many days you're gonna have.
Exactly. That's actually one of the problems. I have no idea ahead of time. Like maybe they're going to give me 100 days, or maybe
Right.
they're going to give me 17 days numbers. Okay. So I have a hard time making variables ahead of time when I don't know how many I'm going to need. So that would be a good way to get reminded, would be to store every day's temperature in its own variable. Okay. But we don't know how to do that yet. Okay. So that would be a great way to get reminded. Store all these numbers in each one in their own variable. But instead, they're all being stored in this one. And as we store a new one, we lose the last one. How else can I remind this program of what the data was? Come up with another strategy. If somebody gives you a list of numbers and you forgot what the list of numbers was, what do?
Ask for the list of numbers again.
Yeah, ask again. So
Oh,
ask again. So you can just, okay, so take this loop here, put it down here, and ask again, okay? But now you wouldn't add the numbers into the sum. See, just ask for the numbers again. Okay, now let's see. What we want to know is how many days were above average. So here's what I would want. I want another, instead of an int sum, I want an int above average. And I start with the idea that there's 0 days above average. Okay, so I'm going to, now, what do I do here? I'm
Can you
going,
do if?
Pardon?
Oh, I was about to say, couldn't you do if next is greater than average, and then just increment the above average?
yes, exactly. See, now we have to decide if we want strictly above average. Okay, let's do really strictly above average. If next is really above the average, then I do what? If next is really above the average, I do what?
Increment.
Increment my variable that's the counter. Okay, and then, okay, now that'll work. See, I'm going to go, now the user has to type the numbers in all over again. Yeah, I asked them for the number, they have to type their numbers in over again. Then instead of adding them into the running total, now I can compare them with the average. Okay, and then I keep a running total. Now what do I do? What's the last thing to do?
Print it.
Print it. Yeah. So I'll do a little copy and paste here. Days above average equals okay. All right. So let's see. My numbers were 3, 6. I don't know if I can remember 3, 6, 7, 2, 9. Okay. So let me. Okay. So 5 days, 3, 6, 7, 2, 9. Okay. The average is 5.4. 3, 2, 7, 6, 9. And there were 3 days above average. Okay. Because we kind of know. Yeah. So, yeah. But the disadvantage here now, this is actually not an uncommon thing in the real world. It's not uncommon to have sequences of numbers and that you have to play them twice. You play them once through a program to create maybe an average, then you play them the second time through the program to do some other calculation. So we had to run our sequence of numbers through the program 2 times. Okay, all right. Now, but let's find a better way to solve this problem. Instead of having to ask the user to enter the numbers 2 times, there's a better way to do this. Remember, the idea was that we'd really like a variable for each one of the days, but we didn't know how many days they're going to be. So we didn't know how to create a variable for each one of the days. And this is exactly the problem that arrays solve for us. Arrays create large numbers of variables at once. Okay? So we're going to solve this problem using arrays. So let's step aside and talk about what an array is, and then we can go back to this problem and see that we can solve this problem more elegantly. Yeah, and by elegantly I mean we won't have to ask the user to give us the number 2 times. We'll ask the user to give us the number 1 time. We'll store every day's temperature in its own variable in a certain way. And then once we have all the temperatures, we can compute the average and compute the number above average. We'll still need 2 separate loops. We'll still need to run through the data once to find the average, run through the data a second time to find out how many numbers are above average, but we won't have to ask the user for the data. In fact, what we'll do is we'll do 3 loops. We'll do a loop to ask for the data, a loop to compute the average, and a loop to compute the number of days above average. We'll just make it, we can't make it 1 loop because you can't find the number of days above average until you computed the average. You could combine, like here, we're combining finding the average with reading the data. So you could combine that into 1 loop, or you could break it up into 2 loops. You could do it either way. Well, this one cannot break it up into 2 loops because every time it gets a number, it needs to put it into the sum right away, because when it loops around, that number gets lost. If we're going to read the numbers and put every number in its own loop, we can read them in one. If we're going to read every number and put its own array, we could read all the numbers in 1 loop, compute the average in another loop, compute the number above average in a 3rd loop. So, but first let's figure out what arrays are. Okay, the idea is an array is a large number of variables. Okay, all right. So let's go to the Java visualizer, because the Java visualizer is a real nice way to see arrays. Okay, an array is a kind of object. You know, we've seen a few kinds of objects, like string objects, or for example, scanner objects. Yeah, here was a scanner object. Okay, so here's an array is a kind of object, and let me just create an example. Okay, I'm going to create what's called an integer array. So I say int. Now remember, if I do this, I have one int. It's an x. But I'm going to do this. This symbol here means array. Okay, now x is now, this is where trinkets get tricky. X is an int. X is an array. No, but X is not an array event yet. X is a name for an array event. Okay. Oh, let me go back. Here's something we have to worry about. String S equal HELLO. Let me remind you of something, a tricky thing. How many strings do I have? Type correctly. How many strings do I have?
2.
Yeah, but I have 4 of something else. Okay, see the confusing thing, well, you know, 2 is the right answer. I have 2 strings, but I also have 1, 2, 1, 1, 2, 3, 4. But I have 4 things over here called string. Does anybody remember what I have? What's the right answer? What's going on here? Before I draw the picture, visualize, draw the picture. But what was going on here? There's 2 string, you know, what are the words?
Objects.
2 string objects and 4
String variables.
string variables. Yes. 4 string variables pointing at 2 string objects. Whoops. Oh, forgot the closing quote. 4 string variables pointing at 2 string objects. 3 of the variables point to one of the string objects, and one of the variables points to the other string object. 2 string objects, 4 string variables. Okay, arrays are like this. There's a difference between an array variable and an array object. So arrays act this way. Okay. Now, now let me switch to, now if I do this, that's an integer variable. Now, what do I mean by that's an integer variable and that's not an integer object? How do you explain that to someone? That's an integer variable and there isn't any integer object here. Why is that? What's the picture look like?
It's gonna be 5 inside of a box.
Yeah, and the box is where?
Over on the side with the variables.
Yeah, it's actually it's X itself. See, there isn't an arrow. The 5 is actually just right there. See, 5's right there in the variable. See, these variables hold the arrows to the objects. So the value is over here under objects. Here, the value is right in the variable. There is no object. What's the name for this phenomena? versus this. There's an adjective here. This is a blank variable. This is a blank variable. This is a,
Would it be literal?
oh no, literal is the 5. That's a real important word. 5 is the literal. It's literally the number 5. Okay, so 5 is the literal. X is a blank variable. There's a lot of things you could fill in the blank with, like X is an int variable. That's not the one I'm looking for. So X is an int variable. But there's another thing you could fill in that blank. It compares it with this kind of variable. Some of the variables hold their value, and some of the variables hold arrows. And we have names for each. Pardon me?
Is it primitive?
Yes. X is a primitive variable. Primitive variables hold their value. And these are called what? They refer to some object. So they are called
Reference.
reference variables. In C++ and C, they're called pointers because they point at objects. I don't know why Java chose a different name, but in C and C++, they're called pointers because they point at something. But Java doesn't like the word pointer. Java calls them references because they refer to another object. So primitive variable, this is an integer primitive variable. This is a string reference variable. So if I say, what's the blank in front of the word variable, this one's got 2 things you could fill in the blank with. It's a string variable. It's a string reference variable. It's a reference variable. This is an int variable. It's an int primitive variable. Okay. All right. Array. Now, let me go back here. Now, if I put a square bracket over here, that changes what X is. It's not an int anymore. It's not a primitive variable. It's now a reference variable. See, the square brackets after the int make it a different kind of thing. This is now a reference variable, and it references an object, which is a new int array, and I'm going to say, and I have to say how big it is. Okay. Now, what this does is, this is my way of creating a bunch of variables with the same name. This is a way of creating a bunch of variables at once. Okay. Now, watch what happens when I visualize this. See how X points to a box over here with a bunch of slots in it. Okay. Now notice this. It's a lot like a string. Remember, strings have entries 0, 1, 2, 3, 4, and by has entries 0, 1, 2. An array is a lot like a string. Think of it as a string that's holding ints. In this case, it's a string that holds ints. There's int 0, int 1, int 2, and I kind of hate the way they abbreviate this. Notice that they should show all the slots. There's 5 slots. Slots 0, 1, 2, 3, 4, and 5. Okay. Now, they chose to abbreviate. I don't think you can get rid of the abbreviation. Let's see. I don't think that will get rid of the abbreviation. No, it didn't get rid of the abbreviation. And I don't think this one does either. No, didn't get rid of the abbreviation. There's actually 5 little boxes over here. Okay, that means that X is a name for 5 boxes. Okay, now here's how I access each box. X with a square bracket and a 0 after it is the first box. I'll put 22 in there. Okay. See how I put a 22 in that box? See, I created 5 variables all at once. They're called X0, X1, X2, X3, and X4. X0, X1, X2, X3, and X4. Okay, and I just put 22 in X0. And now I'll put I'll jump over to X4 and put 17. See, I put, now notice that there's no more abbreviation. Yeah, I got now notice that I got these, I didn't put anything in X1 and X2 and X3. They are automatically given the value 0. Okay, so this is one thing about arrays. Arrays give you automatic values. If you don't put something in an array, it holds 0. So this created 5 variables. Well, but it's confusing. Different people want to think about it a different way. It created one variable called X, but it's an array variable. It points at 1, 2, 3, 4, 5 slots over here, which you can think of as 5 more variables. So X is the reference variable that points to the array, which holds 5 more variables. Those variables have the names X square bracket 0 square bracket, okay? And I can put anything I want in those. Like now I can go and give X2 a value. I'll put a -15 in there. Okay, see, I can I can put any number in any one of these slots, and I can access them. I don't have to access them in order if I don't want. I don't have to go 0, 1, 2, 3, 4. Notice here I went 0, 4, 2. And I haven't even touched 1 and 3, and they're just holding their original value. Now, if I go back to the beginning, if we step through this, okay. Now, line 7 is about to create the X variable over here. It's about to create the array over here. The array by default will have zeros in it. It's going to have 5 slots of 0 because I haven't told it otherwise. I didn't say what to put in the array, so they put zeros in the array. And then X becomes an arrow pointing at that array. So X is an arrow pointing at the array. I wish they didn't abbreviate it, but there's 5 slots, all of them with zeros automatically. They're not empty. They actually have zeros in them. Then I started putting some things in them. I put a 22 at 0. I put a 17 at 4. I put a -2 there. And if I want, I can go back now and I can take X0 and put 88 in it. See, I can update a value if I want. Put 22 there, put 17 there, put -15 there, and then I can change what's in 0. So yeah, I can make this one update. I can change these anytime I want. They're just like any other variable. I can change them anytime I want. Okay, and I can change the size of this guy. So here's a size 10 array. Now that variable X is a pointer at a list of 10 variables, an array of 10 variables. They all hold zeros. And then here, some of them get filled in with something other than 0. Okay, so there's the string part. Okay, now now notice that, see, they do the abbreviation thing. I wish they didn't do the abbreviation thing. So there's a box at 0, a box 1, box 2, box 3, box 4, up to a box 9. So that's 10 boxes. So I'm asking for 10 integer boxes. If I put a 0 at 22, notice that it's still notice how this is just the way the visualizer works. When I put something in at 4, it expanded this thing up to 5, and then it did the ... dots. ... dots, they even have a name. When you do this kind of abbreviation, when you do a ... like that, it's called an ellipsis. So this is the standard symbol to mean you just, you continue on until you hit this thing. Okay, so if I go back a step, notice that the ... dots were between 1 and 9. So that meant from 1, you go all the way up to 9. So that the ... represented 2, 4, 5, 6, 7, and 8. But then when I put something into 4, well, they expand it out to 5, and then they do ... 6, 7, 8 now. The ... now is 6, 7, 8. Okay, so I wish they didn't really use the ... dots, but they're trying to keep the picture from getting too cluttered. Let me show you why they do the ... dots. Later on, we'll do 10,000 here. Oh, Yeah, see, the Java visualizer didn't like me doing 10,000. Java doesn't care if I do 10,000. The Java visualizer doesn't like it that big, unfortunately. Let's see, it probably did not let me get. Oh no, it actually created 10,000. See, there's 10,000 slots. See? Oh, and that's where it died. Somehow it died. Maybe it wasn't it wasn't because it might not have been because I created 10,000. It might just be there's too many people using it. Let's try again to see if maybe it was just too many people are using their website. That still didn't like it. Okay, but see, you can create huge arrays. It's not unusual in the real world to create arrays the size of 1,000,000 or even millions. Okay, let's see, let's create one of 1,000. So there's 1,000. See if that goes through easier. Yeah, okay. Okay. Now, what can I do to try to get them to get rid of all those dots? Does anybody have what would I do to try to force all those dots to go away? What can I do to try to get those dots gone?
Fill in the boxes.
Well, how many of them? I don't want to fill in 1,000 of them. That's going to take too long.
Maybe try 1 every 10.
Something. What might work much faster?
0 to 999.
Pardon me?
From 0 to 999.
Well, I don't know what you mean by from 0. What can I do to try to get them to get rid of these dots? Something. What would be a simple trick to try to see if it works? What happened before? Pardon me?
Fill in the last one.
Yeah, try the last one. Let's just go ahead and try putting something in the last one. Because remember, it seemed that they expanded out as I went through. So I'll put 10 in there. Okay. Now notice how, watch. See, now it's just 0 dot 999. Now it's 0 1 dot 999. Now it's 0 1 2 3 4 5 dot 999. Okay, so now the question is, what are they going to do now?
Oh,
They cheated us. What did they do?
they didn't do it.
They didn't do it. They still did. They dotted everything between 5 and 998. Okay, so they're trying hard not to write out the whole array. You know, it's just their choice. They're trying hard not to write out the whole array. Let's try 100. Let's see what they do with 100. I know that sometimes they will draw out the whole array. Not again. See, they kind of, you know, so you just have to be aware that when you see this picture, the dot means there's a lot between there and there. There's entry 6, 7, 8, 9, 10, 11. Okay, and now I could, like, what do you think will happen if I put something in the middle?
There's gonna be 2 areas of some dots.
I bet that's what they'll do. Yeah, I bet they'll go up to 50. They'll do some dots up to 50, and they'll do dots after 50. And not that it really matters, but we're trying to think about, you know, what is it they're trying to do? You know, we just want to think about how these things kind of work. And yeah, see, they put 2 dots. They're trying not to show. Now, what do they mean by dots? What is in 6, 7, 8, 9, 10 up to 48?
Straight zeros.
Straight zeros. Okay, so that's why they can put dots there, because we didn't put it when the array is created. Everything is 0. We've put in some numbers, and the ones we haven't touched are still zeros, so they can comfortably say that between 51 and 98 is all zeros. So the dot. So here, this dot means, like, notice it. This dot means something different than that dot. Okay. Tell me what this dot literally means. You read it as the dot on the top row means what to you? Telling you to do what?
like skip through all those, I guess.
Well,
So
well, think, yeah, because see now, do you see what there's something different? Tell me what this dot dot means versus different than this dot dot dot.
okay, so the top one is the array number, and the bottom one is the value inside the array.
But what's it saying? This is saying what about what? This is telling you to do what?
Skip all the way to the next to
Well,
90.
not really skip. Yeah, what's it telling you is there's something between the number 51 and the number 98, and it's saying you should be able to figure out for yourself what's between 51 and 98. What is between 51 and 98?
The same thing that is 51 and 98.
Pardon me?
51 and 98 each have 0. It's implying that everything between those is 0.
But there's two dot dot dots. See, you're mixing up the fact that this dot dot says something a little bit different than this dot dot.
The top one merely means that every integer from 59 to 98.
It means count from 52 to 98, right? It means count up from 51 to 98, right? What does this one mean?
The index is 0.
No,
Each
the
time.
index is this guy up here.
The value stored in there is 0.
Yeah. So this, let me show you something. Let me. This is not a trivial issue right now. This is something that you'll see this in a bunch of programming languages. Suppose I write what's dot 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 mean?
The pattern that is continuing.
What does it mean? What pattern?
It means that it's suggesting the sequence that you're adding 2 to each number.
Yeah, it means it should mean go up by the even numbers, right? But okay, now what does this dot 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 mean?
Going by ones.
Go up by ones. Okay. What does that pattern mean?
1 every time.
Yeah, see, it means a different. See how this pattern means just. Now it doesn't tell me how many ones, but it means keep going 1 1 1 1 1 1. This means go up by twos. This means go up by ones. Okay, we're back over here. What's this dot dot dot?
It's 0 every time.
No, I'm highlighting the dot dot dot. In
You're
the
adding
upper.
by 1 every time.
Up by ones. See, that dot 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 is like this dot dot dot. It's up by ones. What's this dot dot dot?
0 every time.
Yeah, it's like this dot 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 that said repeat the 1. This one says repeat the 0. This one says repeat a number over and over again. This tells you this says add 1 to a number over and over again. They don't mean the same thing. They expect you to figure out what they mean, and they don't mean the same thing. This is a little thing, but believe me, as programmers, you're starting to get to where you have to know what every little symbol on the page really means. So I'm kind of pushing you to think, if you see a comma, you have to tell me what the comma means. If you see a semicolon, you got to tell me what the semicolon means. It's not English anymore, where you can gloss over a lot of the stuff that's on the page because its usefulness is borderline, commas, punctuation. In text messages, most people don't even bother with the punctuation. You can still get your message across. Programming doesn't work like that. If there's a comma on the page, you got to tell me exactly what that comma means, because it could mean one thing in one place. It could mean something real important to understanding how the program works. So here we're trying to figure out how they're using dot dot dot. Up here it's meaning continue the indexes by ones. 1 2 3 4 5 6 7 8 9 10. Okay. Here they're saying continue the entries 0 0 0 0 0. Okay. So there's a pattern to the entries. Here the indexes are up by 1. Here the entries are all zeros. So these are called the indexes. The highlighted things up here are called the indexes. These are the entries, what's in the variable. This is part of the variable name. The variable name is x square bracket 0, x square bracket 1, x square bracket 2, x square bracket 3. So the index is part of the variable name, and then this is the value that's stored in the variable. This is the value, the entry. We sometimes use the word the entry in the variable. Sometimes we use the word the value in the variable, okay? So when I declare a array, I'm really getting a whole bunch of variables at once. Yeah, I can even get massive numbers of variables, thousands or millions of them. And I'm creating a bunch of names. Notice that based on this part here, I can build new names now. This is the key is that I can build new names. From X, I can create that name there. Now be careful. X by itself is this arrow pointing at the array. So X by itself is a variable, but it's not well, we call it the array. So X is the array, but it's actually of not that much use. We'll see that the X by itself usually isn't very useful. You have to, what we call index into the array to get me a specific value or entry in the array. Okay. So when I declare an array, I get a whole bunch of new variable names. Now, arrays are like the strings above. I can do the following. I'm about to create another integer array reference variable. Anybody want to guess what that does?
It creates a new array variable that goes to the same array object.
Right, so what do I see in my picture then?
2 arrows.
2 arrows. Just like
okay.
we saw multiple arrows pointing to the strings, yeah, we'll see multiple arrows pointing at the array. Okay, now, what does, what's in, what's kind of interesting about that?
It's going to change the value.
In what?
4.
At entry 4 of what?
4 of the array.
Yeah, and what about, but we have, we have one array, so we're changing that. But what's interesting, we have 2 names for the array, so what do I also have to realize when I do this?
X and Y are mutable.
No?
Okay.
Yeah, they are. They're changeable. What's in the 4th entry in the array?
Oh, 17. So that means that'll change to -2, which is the last entry.
Right. Okay, what happened to the -1?
It's gone.
Because,
Because the thing gets saved in a variable. It's gone.
well, yeah, but what, the key, what's this and this? Why would somebody think that there's a -1 somewhere and there's a -2 somewhere? See, they look at this code and they think, you've got a -1 stored somewhere and you have a -2 stored somewhere. The -1 is in Y4 and the -2 is in X4.
Because you gave 2 names for the same array.
Yeah, because there really is only one array. This is why arrays can be tricky. You can confuse the heck out of yourself if you end up with 2 names to one array, because you might think you have -1 in one array and -2 in the other array, but they're actually the same array because you didn't pay attention that somewhere they actually were the same array. So if we look at this, okay, there's the 2 names for the same array. Change the 4th entry, change the 4th entry again. See, and the -1 is gone because when you overwrite a variable, what the value that used to be in it is just gone. When you overwrite a variable, like somebody say, when you overwrite a variable, what was in it is just disappeared. So there isn't a -1 in memory and a -2 in memory because they're the same variable. X4 and Y4 are the same variable because we have two names for the same array. And that can get real tricky. This can cause a lot of confusion if you accidentally do something like this. Okay, and we'll see why you would have two names for the same array. There are good reasons to do this. We'll see when we would do it, but we have to be careful to realize that when you have two names for the same array, there's only you're overriding this, and this puts a number in the same place over here. Okay. Okay. Now notice that this is why this section is called arrays and references. See, it's called arrays and references because what we're talking about is the array object, which is this guy over here. But just as important is the idea that we use reference variables to refer to the array. So we got to be very careful that we understand when two reference variables may or may not be pointing at the same array. For example, what if I wanted y to be a copy of x? What if I didn't want y to be another name for x? What if I wanted it to be a copy of x? That's something we have to talk about eventually. Like, it's easy to get, like if I have int a equal 4, int b equal a, I get a copy of 4. That automatically copies for me. A and b are not tied to each other. See? Now I'm about to create A. Now I'm about to create B, and I copy A into B. So I copy the 4 into here. Now if I change A, it doesn't have anything to do with B. I didn't get that over here. See, I got that automatically here. I got a copy here. I didn't get a copy here. Okay. There are programming languages where this gives you a copy of an array. Java isn't one of those. But there are languages where if X is an array and Y is an array, and you say Y equals X, well, Y is a copy. So then there'd be two arrays over here with X pointing to one and Y pointing to the other. There are languages that work that way. You could easily make, they could have decided that Java would work that way, but they decided it would be a bad idea. When X is an array of 1 billion items, you don't want to just make copies of it. So the justification for not copying here is that X could be huge and copying could be silly. It could take a lot of time and waste a lot of time in memory. So Java only copies when you specifically ask it to copy. You have to really say that you have to do something special to get a copy. But for something like this, copying is easy. There's no big deal to make a copy of A and make it B. So Java copies primitive variables, but it won't copy reference variables. It won't copy objects. This object does not get copied unless you do something special. So when you do this, you get another name for the object. Okay. So that's why that's why it's important to talk about arrays and references simultaneously. Okay. Now, ints aren't the only thing I can create arrays out of. If I put square brackets after the word double, now let me do this. What do you think I have now? Actually, the visualizer didn't even like that. Look, the visualizer skipped over it. Wow, that's kind of goofy on their part. What do you think I have here? This is really awful. The visualizer is not doing the right thing. What do you think this does?
You're gonna create an array with doubles instead of integer values.
Okay, now be real careful.
All right.
Here we had to distinguish between two things. What were they?
The length.
No. Go back. Okay, I'm at line 6. I'm about to do line 7. Haven't done it yet. What's line 7 going to do? Real gory details. Line 7 does what?
Gory detaily.
Okay,
It
does
creates a array called
okay,
F.
now, yeah, now, now, who did that? What? Here's a line of code. Which letters in that line of code created the array?
The brackets
A little bit more than that.
and the new and the 100.
Yes. Yeah, the new int 100. All of this creates the array of, okay, that creates the array. That's one thing. What else did line 7 do?
It gave a name to it.
So that did what? Think of the picture it's going to be over here. This created the array over on the right-hand side of the picture.
Right. And then
Then
that
what else happens?
created the variable and the arrow,
Well, this creates the what?
the array, the variable.
The reference variable on the left side of the picture. This does what?
Draws the arrow.
That draws the arrow. That's like literally, those are the 3 steps, and they're the 3 parts of this thing. The right-hand side, the left-hand side, and the thing in the middle. They do 3 things. Create. Now think about this guy. This guy did only 2 things. See, notice this thing did 3 things, but this thing only did 2 things. What 2 things did 14 do?
The variable and the arrow.
Yes, but no what?
No new array was created.
Yeah, exactly. No new object here. So this line 14 only did 2 things. It didn't need to, X is already there. It created the variable, and then it created the
Arrow.
arrow. Okay. What if I, what's now, okay, so this did 3 things, creates the array, creates the variable, and makes the variable point at the array.
Right.
This did 2 things.
Right.
Well, it created the variable and put the arrow in it, pointing at that, copied the arrow from X to here. So what's left in this guy? What does he do?
One thing.
One thing. He does what?
Creates the reference variable.
Yes. And you probably don't, you may not know this. What would be in the reference variable when it's created, but nothing's put in it? We've mentioned it briefly a couple times, but we haven't emphasized it. Does anybody remember what is in the reference variable?
Null.
Null. Yeah. And
Wow. Guess.
yeah, no, nothing. Null for nothing. Okay, now if I actually write the word null here, maybe the visualizer won't skip over it. I think if I write the word null, the visualizer won't skip over it. There. Okay, so for some bizarre reason, the visualizer wants me to write the null there. Okay, so there's the variable with, now notice that only did one thing, created the variable. Now, there's no object, there's no arrow, but there is a null. You could say it did 2 things. You could say it created the variable and put the word null in it. If you want, you could still argue that it did 2 things, created the variable and put the null in it. Okay, now if I want there to be an object, I can make that on here. Now here I'll make the object separately. I'll make the object on a different line. Now I'm separating creating the variable from creating the object. I put them on separate lines. It's nothing wrong with that. It's perfectly okay to do that. Okay, so line 19 creates the variable, and line 20 now creates the object. Okay, and oh look, something interesting.
No dot dot dots.
No dot dot dots. Yeah,
That's crazy.
Yeah. Yes, definitely great. Yeah, that leads me to wonder what happens if I do
Oh. Oh.
Yeah. I mean, okay, go ask the programmer how he was thinking about all this.
Wow.
No, so what are programs? They're things that humans create. Who sets the rules? Whoever's writing the program. How do they set the rules? Hopefully, consistently and intelligently, but not always.
Not a Java visualizer.
Pardon me?
Said not a Java visualizer.
Yeah. No, I think the job visualizer is great. I really love this thing. But it's only been around a couple years. It's very much in development. You can see how I bet the dot 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 is what they really want. They probably forgot to do the dot dot dots here because this is kind of hokey. This actually is kind of weird. Yeah. Yeah. There are literally 1,700 little boxes there.
Jeez.
Just, I've got a question, Professor.
Uh-huh.
So is this the one and only way you write arrays in Java? Just because I'm looking at, I know in different languages, you assign it and then you actually put the array on the other side of the assignment operator and
I'm not
plug
sure.
in your numbers.
Can you tell me what to type so I can type, like, what do you mean? Like, give me an example. What would I type?
So you could just say, for example, int x is assigned an empty array.
And then what? Oh,
An
how
empty
do I
array,
do that?
just the two brackets,
Oh,
and then like that, something like that.
that's not an array. That's
That
a
would not
list.
be. That would be a list. Okay, I
Yeah,
see.
that's not an array. That's a list, and that could either be Python or JavaScript. But
Okay.
when the brackets are empty like that, that's not an array. That's what's called a list. And Java doesn't have. Well, Java does have lists, but you write them a different way.
I see. Okay.
Yeah. See, what makes an array is when you put the square brackets after the. Now, Python doesn't really technically have arrays. It only has lists.
Mhm.
And JavaScript has both, if I remember right. Okay.
Okay.
So the square bracket notation is commonly used for both lists and arrays, and this one would be a list.
Okay. So for Java, what would be a list? Would be an array as well, or would be,
No.
Okay.
In Java, you actually write it. In Java, you have to do the following. You have to say. You do it like that, and then you have to say what it's a list of. So you would have to say something like list of integer.
Oh wow.
And you would have to then put. There's how you create a list in Java, a list of integers.
Okay.
Yeah, and that's an empty list of integers, and the notation is very different than in languages like there's no square brackets anywhere.
Mhm.
Yeah, there's no square bracket, but that's the proper way to create a list and that's also the notation for C++. C++ uses the same notation.
With the capitals and everything.
Yes, yeah, and the little diamond. We call this the diamond operator, with the diamonds here. So C++ would write it the same way. Okay, so but at lists in Java, lists and arrays are pretty different. In JavaScript and Python, lists and I think in Python, let's see, which one is it? In Python, I can't remember now. I think it's Python doesn't even have arrays. I think Python lists and arrays are the same thing. And in JavaScript, I think there's a difference between them. I don't do much with Python and JavaScript. I don't use them day to day, and I keep forgetting. Yeah, I use it 1 month now, and then I won't use it for a few months, and then I'll forget. Okay, all right. So what we're talking about, we run out of time. Okay, so we've been talking about this create. Now what we're going to do is go back to our program, not now, but we want to go back to this guy and see how we can use an array when we're reading in the numbers. We put them in an array. Does anybody see? There's one last question. Why is it that I don't need to know how big the array is before I run the program? What if somebody's going to give me 7 days, but somebody else is going to give me 107 days? Let me see what the difference. Let me see the beauty of that. We're going to do something like what's the nice thing about line 13?
So now whatever number they put in, it's gonna create that long of an array.
Yeah, I don't have to know before I write the program how long that array is going to be. When the program runs, it creates the size array it needs. So when I ask the user, how many days do you have? If they say 27, then I create an array of 27 entries. If they say 57, then I create an array of 57. I don't need to know, this is what makes them so useful. I don't need to know before I write the program how many entries there are in this array. I can ask the user, how big do you want it to be? Then I make it that big. Okay, so that's where we'll stop. Okay, that's what we're gonna add the array to this program, and then we'll be able to go through the data twice, once to fill in the array and create the average, and the second time to find out how many days we're above average. Okay, so that's what we will do. Okay, so we've run out of time. So look for your exam. I hope tonight, I hope this evening, and look it over. Oh, I didn't want. Look for your exam. Look it over. If you have questions, send me an email. Look them over. Okay, I'm gonna go ahead and let's see what I want to do. Stop sharing. Okay, and so we'll meet again on Wednesday, and read the sections on arrays, and then we'll do more details with arrays on Wednesday. Okay, bye.
See you later.